Hi students, the grade 10 syllabus is the current electricity. It's a unit 9, it's a very important topic in the grade 11 and A level and another subjects, but the current and electricity already you study about this grade 6 and 7 and grade 5 also, but here the grade 10 the important things is a grade 11 O level final paper is structure and essay question. There are a lot of marks in important to the current and electricity. The main concept is important to identify the current, voltage and amperes and symbols and everything is also there. But here current and electricity first introduction to start. Now is charges already the grade 7 and 8 syllabus is also there in the static charges, but here the static electricity and current electricity. The main concept is all matter is made up of atoms. The matter is consist of grade 8 syllabus is also there. The matter atom matter is made up of the atoms. Atom is contain protons and neutrons and electrons, but the atom is a neutral bodies. But here the center part is a proton and the other part is a center is a proton and neutron and other orbit is circulated in the electrons. But all the matter is made up of atom. Atom is a neutral body. But then electric charges, here the main things, the electric current is produced in the movement of charges. Movement of charges mean here the positive and negative, but the important things the electron is moved, the current is also produced. The later grade 11 is also study about this poles mean the semiconductors. Semiconductors is conductors a positive charges also there, but here important law of electric charges. The electric charges state that like charges and repels and opposite charges also attracted, but repulsion and attracted the magnetic field is also there some like that same like charges and opposite charges. The protons are positively charged, the electrons are negatively charged. So, they are attract to the each others. The proton is mainly the positively charged and electron is negatively charged. So, they are attracted to each others. Without this attraction, electron would not be held in atoms. Here the attract negative opposite charges in the unlike charges and like charges, but law of electric charges already grade 7 and 8 syllabus, the pit pole electroscope and home here is rubbing with each others. Here the simple thing is made of the charges is created, the temporary charges. This is a static charges. And charge object atom do not have the charge because the number of electrons and protons cancel to each others, because atom is the 3 protons, here the some atoms is there, the equal number of positive charges and equal number of negative charges. Negative charges mean the electron is a negatively charged, proton is a positively charged. So, the neutral body, this is a atoms. But here the important thing, the charge object to object charge, they are either gain or loss electrons. Mainly the resultant is protons. Protons mean the negatively only the electron is moved. The electron particle is electron is moved, there are no movement of the positively, the positive ions. The only the electron is losing or gaining. Electron is losing or gaining, this is a charges is also created, but here the 3 proton and 5 electrons, the resultant is here negatively, and 7 proton has 2 electrons, here electron is less amount. So, the positively the resultant positively charged. The main things the only electron is moving. And charge, how can you charge object is there are 3 ways object can be charged, the friction, conduction and induction. This is the simple thing is the static charges. The friction is charged rubbing with a 2 things, the electron wiped out the PVC pipe and polythene or any other cloth. This is a simply charges is created, and conduction is also. The conduction happens is the electron move from one object to another through the direct contact. This is a touchings. They are supposed to touch uncharged piece of metal, the positively charged glass rod, and electron from the metal with the move to the glass rod. Here the important things only the electron is moving, the glass rod and other piece of metal or any other things, the electron is moving. This is a temporarily, this is a static charges, temporary charges also created. And induction, the charging induction happens when charge uncharged object we rearrange without a direct contact or charge object. This is a simple thing, is a balloon is wrapping with some polythene or any other things, they touch with other papers. Also here this is the temporary charges also created. The simple experiment is also there, create 7 and 8 syllabuses, but static electricity also uses here a lot of the things in photocopy machines and other the cameras. There are a lot of things in the appliances also, static electricity charges is used. And static charges is created, the simple experiment is also there in your textbooks, with a piece of PVC tube and polythene bag and neon bulb conducting wires. This is simply the neon bulb, the tester is also there, the neon bulb. Here they arranged set up the connecting conducting wires of neon bulb, and PVC is wrapping with a polythene, and touch terminal of the neon bulb in the charge rods, repeat above steps several times, observe lightning of neon bulb. Here this simple charges, the PVC is wrapping with the polythene bag, and other end is connect with the neutral body. Neutral mean the touch with the finger or anything, and the other wires is also PVC is simply touch. The neon is lighting quickly. And the small experiment is also there. This is a video experiment. This is how to create this static charges in the neon bulb. Right. This is simpling the lighting up the neon bulb. Here the neon bulb is there, in the and the other part is connected in the PVC, rubbing with the PVC tube, and other end is connected, touch the finger and the other thing, because the current is static charges also created. Bulb is also the emitting here, they observe clearly, this video is there, the small bulb in that thing, normal testers like that. The tester is also the neon bulb also there, but they observe the picture is clearly what other finger is touch with the finger, and the other end is a touch with a PVC tube. Here touch, they observe the lightning, the light up of the neon bulb, the small current is also passes, the touch with the neutrally, and after that the electron is passing through it, the current is also passed. This is the static charges. Now, we observe the this is a very little charges is also passing through it. The concentrately the observing the neon bulb, the little charges also create and passing through the current. Right, this is a simple experiment. Also, your textbook is the PVC wrapping with the polythene, touch with the terminal end of neon bulb in the charge rod, repeat above steps and several times observe lightning of the neon bulb. Here is a simple experiment. This static charges is created and passing the electron is important to the main thing is conductor electricity. The electrostatic charges are stored on the surface of PVC rod rubbed with the polythene. When it touches the conducting wires with the stored static charges begin the flow of via the conducting wires. When these charges flow through the neon bulb, it lights up, and when static charges begin to flow in this manner is known as the electric current. This electric current is created here, the charges, mainly the charges is passed through these conductors. The current of electricity charges flowing through the conductor is known as the electric current. The current of electric charges, important things is electric charges flowing through the conductor, and the electricity flowing through the conductors. There are two things is important: the conductors, electric conductors, and electric insulators. But here the electric conductors, mainly the metals, most of the metals are conduct electricity because there are freedom electrons. The freedom electrons, sea of free electrons, the important, the metals is also positively and the electron is also there. The freedom electron is important, conductor electricity is a conductors, electric conductors, and The atom is also there, the positive and negatively, but the important thing is the free electron is conducting. The conductors, mainly the electrical conductors materials which charges can move easily, and the most of metals are good conductors because there are a lot of free electrons, the free to move of electrons. Those are the metals, mainly the periodic table. You have to know that the 21 to 29 and copper is also 29 very superconductor because there are free electrons, high free electrons, and silver is also the conductors, and iron. This is the conductors. The conductors are used to make wires. For the example, lamp and cord, this is copper and aluminum, and mercury is also the good conductors. The mercury is also liquid metals, but conduct electricity. And other insulators. Insulators, the electric insulator is the material which charges cannot move easily. Some statement is also there, the past paper question is there. Some of the electron is there in the conductors, and insulator there are no electrons. This is a wrong one. Statement is wrong because they are free electrons. The important thing, the free electron is important to carry the charges. Free electron is moving and conduct electricity. Normally the insulators and conductors is also the atoms. Atom is made up of electron and proton and neutrons, but important things, the conduct electricity, the free electron is moved to electric charges, the created. Do not conduct charges will because there are electrons cannot flow freely. Important thing, they cannot flow freely. Their electrons are tightly held in the atoms in the insulators. The free electrons, there are no movement of electrons. They packed with a closely, this is insulators. The insulating material in the lamp cord to the charges from leaving the wire and protect you from electric shocks. The plastic and rubber, glass, wood, and air, and some other insulators, some examples of insulators. And electric current, the important, they already know that these charges, the electric metals, and how to metals is conduct electricity, because the flow of electrons through the conductor like silver and copper and gold and aluminum is there. The metals positive ions is there, the free electron is also there. In here the blue color is moved. There are some examples in the electrons. Electron is movably, the randomly movement. But here the electrons move in no particular directions. The electron is moved in irregular patterns. But here the electron is moved in a one direction. So therefore, this is electric current because there are the potential difference. The potential mean the conductors put in the some voltage difference. The electron is moved the one directions. So electron is moving this one, the current passing through the opposite directions. Important things. The electron is moving this one, direction is here, and current passing through the other direction. Normally there are no movement of the positive ions, only the electron is moving. The metals are there, the potentially apply, the electron is moved in the one direction, therefore the electric current is produced. And here is some example is how to the switches on, the potentially the batteries are there, the voltage, the metal conduct electricity. They have the delocalized electrons, mean the free electrons can flow of carry the current. Here the electron is here, this is potentially pushing, this electron is moving, and this one is moved, electron is there, and positively the charges is also, imagine the create this one, the current passing through the conductor, the bulb light is also bulb, lighting the bulb. Here the on, this is the closed circuits, this is the metals, normally the metals mean the conductors, and some insulators, materials, fine ceramics and closed, this other non-metals, but here this metals, this closed circuit, the light is also bulb, light up, this bulb is also light up. Here there are no the insulating ceramics, but here this metals, some metal is touched with the circuit, closed circuit, the light bulb. This is the open circuit, and batteries and switches, the symbol is also there. These are batteries. This is the open circuit. Bulb does not light up because open circuit, there are no passing through the electrons. And here the closed circuit, the important is normally circuit is showing the bulb, batteries is there noting the higher line, and the other one, this is the one is a positively and this one is a negatively, and bulb is also, symbol is also grade 8 syllabus is also there, the cross mark, this is a bulb. but this positively this bulb is closed because the switches. Sometimes this closed circuit is switches is also, this one is open, this one is closed. Light will light up when the switches is closed. And this is the main things is the instruments, some electrical appliances to measure the current and voltage. Here the ammeter. Ammeter is important. A and circle is there. Ammeter reading. This is this instrument is measure the current flow. This is a mark is black color is marked the negatively and red color is positively. This here the ammeter is connected in the series connection, and later is part the how to connect this ammeter and voltmeter. This is the devices. This also there are two different ranges. There are 3 voltage and 15 voltage, but here the 0.5 amperes and 3 amperes. The very milliampere range is also there, and there are 2 reading is there. And here the important thing, the screw is also there. The devices is also center calibration. Center mean the device working in a correctly. So also this screw is also there. Then voltmeter. The symbol is volt V, and symbol is V and circle, and this one is a voltmeter. And ammeter, this one is a ammeter, A symbol and circular path. This is a symbol diagram is important to the ammeter and voltmeter. And now this also the later the very sensitive, all the device, all the instruments, all the electrical appliances are in the one digital one. This is the multimeter. This is a multimeter. The multimeter is also, there are different ranges here, the ampere, milliampere, micro range, and common part is also there, and electrically and backlight here the already is testing of panel, and something the conducting of current passing through the checking in the multimeter also used, because there are similar batteries also there. At the time this is charges, and voltage is also here, and relative measurement, shift button, this is a lot of things is also the multimeter. But you the introduction, the multimeter is used to measure the current and voltage and resistance also. Some devices working in the properly, this instrument is used to properly working in the devices. And ammeter, this is a ammeter here. The ammeter is connected in the series connection, because how to light up in the batteries, how to connect this one positively and negatively, and positively and negatively. Bulb batteries are connected in the series, and here the switch and bulb and ammeter. This current is the switch is off, there are no reading of the ammeter, and bulb is also light up, because this is a series connection. And voltmeter, important, voltmeter is connected in the parallel. Parallel means here the load mean the bulb, the resistance, and voltmeter is connected. There are no through the pass current do not pass through this circuit, but ammeter important current important pass through it, but voltmeter not current passing through it. Voltmeter, this is a parallel connection. The normally the household domestic circuit is also parallelly, because one switch is off and other part is working. So this is a parallel circuit, the bulb and switch and voltmeter. This is a parallel circuit. The voltmeter is connected in the parallel. How to connect this bulb? Here the bulb is there, and this one is a switch and batteries. Ammeter, simple circuit diagram is how to working this bulb. Close switch is a bulb, light is bulb. The reading also there is a ammeter reading. This is a ammeter and batteries. Open switch. Now is a light, there are no bulb light up, because this ammeter is also connected, and then voltmeter. This is the voltmeter. This is a circuit is a series connection, and voltmeter is connected in the parallelly. Now is also this is a parallel connection, voltmeter, and switch off, switch on mean the closed circuit, closed switch. The voltmeter reading is there, and the ammeter reading is there, and voltmeter, the batteries. Here the normally the one battery is 1.5 voltage, 1.5 voltage. Here 6 the parallel, first 2 is 3 voltages the output, because the long term working, because the some 2 is also parallel and other 2 is also series connection. This is simple thing is how to working in the electric current, how to connect this one a circuit. This is simple symbol diagram. This is batteries is noted the this one, and here bulb and then ammeter circle and switches here, but this one parallelly the voltmeter. This is a simple symbol diagram of the electric circuit, ammeter and voltmeter. How to connect this one? Ammeter is a series connection, voltmeter is a connected in the parallel, and switches is also here, switches open switch, and closed circuit simple one. And sometime bulb is also there are 2 or more bulb, the batteries is connected. The important thing, positive and negatively connected. This is a positive and negative, this one negative and positive, and bulb, ammeter, switch, a voltmeter. This is a open circuit. This sometime this one this is a closed circuit. This is a closed circuit. This is a open circuit. This is a simple diagram of the batteries, bulb, and ammeter and voltmeter is connected in the circuit. This is a voltmeter connected in the parallelly, and ammeter is connected in the series connection, and symbol diagram of electric circuit. This is a batteries and ammeter and load. Load mean the bulb here, and batteries, bulb, voltmeter. The voltmeter is connected in the parallel, and then the potential difference and electromotive force. The very important thing is the bulb and the batteries, the electromotive force and voltage. The voltage is output here, the potentially the loading voltage is there. but batteries, the electric pressure is different, known as the potential difference, electric pressure. The unit used to measure the potential difference is a voltage, volt. The unit used to measure the potential difference is a volt, V. But the force is force by which the negative terminal of electric source released to electron to the external circuit, known as electromotive force. The electron is pushing the outside, and this is the negative terminal of electric source released to electron. Here the negative terminal is released to electron to the external circuit. This external circuit known as the electromotive force. This is here a little difference in the electromotive force and voltage. The voltage means the potential difference. Here the potential difference, important, the potential difference, electromotive force, EMF, here the voltage. The battery is internally how much of force is created to the electron is released to the negative terminal to outside the source. This is the EMF, and this one, the voltage is dropping the load, this is the voltage. And the difference between the EMF means the electromotive force and voltage. This is a simple thing, is they understand this one is a EMF and voltage. The earlier this, the later grade level subject is there EMF, how to calculate this EMF and voltage. Now, what is the difference between the voltage and electromotive force? There are little difference between the electromotive force and voltage. This one is a clear understanding. This okay. This grade 10 syllabus. Ohms law. This is the important thing. Is a electric current. This is a Ohms law. This is when temperature is of a conductor remain constant. The current I, the current symbol is I, passing through the conductor is directly proportional to the potential difference. Potential difference is a V. Potential difference that is a constant temperature, important. I proportional to V. I mean the current, the directly proportional to the voltage. Therefore, V over I value is a constant. This is a Ohms is present, is a Ohms law. The V over I is a constant value. This value is K, this one later is R. The constant is known as the electric resistance of the conductor. The unit of measuring the resistance of ohms, the symbol is ohm, that is a V over I. This one is a R. The V over I is a R, whereas R is a resistance of the conductor. This is a particular conductor. This resistance is also depending the type of conductor. This R is a constant value. V over I ratio is a constant. This one is a R. This ohms is represent this a formula. The V over I is a constant is equal to R. The later is a V is equal to IR. This some experimentally proof. This one is a V over I value is a constant. This is R. How to calculate this R? And the unit of measuring the resistance unit is also ohms. Resistance is calculate this unit is ohms value. The Ohms law, this again they repeat, this one is a Ohms law. When the temperature is constant, important thing, the temperature is a constant, conductor remain constant. This term is important. This is not wrong. This one is mentioned the definition. The temperature constant value, because the resistance also depending the temperature. The current I passing through the conductor is directly proportional to the potential difference V. Across it, the constant value I directly proportional to V, and V over I is also constant value. This constant is known as the electric resistance of conductor. This is a V over I value is R. R is calculated, this is R is ohms. Now, this experiment of Ohms law, the important the rheostat. This one is a rheostat. The symbol rheostat mean some type of resistance. There are different type of resistance also there. This one is a rheostat. And the lab experiment, how to connect this rheostat. The very important thing is rheostat, the variable resistor. I think the variable resistor, and resistance is also verified. This is a length depending the coil. Here the coil is there. the nichrome coil is there, and other terminal is touch this one, and C and D and A and B the terminals, and D to C connected, current passing through this one and this one. This one is a maximum number of current, resistance, maximum number of resistance. This rheostat is mentioned 100 value, 100 ohms or 200 ohms. This C and D is connected to the maximum resistance is there, and here the important the value is voltage and current passing is a differentiate. Sometimes this changes in the voltage and sometimes changes in the current. Here the resistance, the changing the resistance and voltage and amperes, and the voltage and amperes mean the current is also differentiate. The connect point A and C, the diagonal connection is point. Here A and C, this is a move, this one current passing here and this one and this one. So, the length increase this to the moving this one, the maximum number of resistance, and close to this one this 0, and length is the sometime connection current passing through this one, the length is increased, the resistance also increase. This is if you want to increase the resistance, rheostat push to slide to the right, this one, and likewise the decrease the resistance push to slide to the left, and current passing through this side and moving right side and left side. If you want to zero resistance, push to slide away to the left, and metal here current passing this one. So, slider this is 0. The metal conductor slider touch the left and silvery surface. This is a symbol of rheostat, the American standard. This is although both are same, but sometimes mentioned here the box and variable resistor or rheostat, the arrow mark is important, and fixed resistor only this one. Or here this is a fixed value, fixed resistor, but here the rheostat is a symbol, rheostat is a variable resistor, resistance is also verified. This is how much of voltage or how much of current is passing through this one, the voltage resistance is also changing the voltage and current. And simple experiment, the Ohms law, the first thing is a batteries positively and ammeter connected in the series connection, and then next uniform resistance, and voltmeter is also connected in the parallelly, and then here the connected to the rheostat. Here the voltage is their fixed value, but rheostat resistance is changing, the particular uniform resistance voltage and current is also verified, and this is a one way of key switch type of key. There are different type of keys there, but one type of key. First the fixing and value reading of ammeter reading value and voltmeter reading, voltmeter and ammeter reading, and the rheostat is changing the resistance and step by step, and there take the different value, and after that draw in the graph, and later is there I and V. This is a graph is also there, the VOY is tan theta, VOY is also there, this one is a R. This is a Ohms law experiment, and this is a circuit symbol diagram, ammeter, batteries, switch, the bracket switch, this one, and rheostat, the variable resistor is also changed, and voltmeter is connected in the parallelly. The simple thing is experiment. In the laboratory there are a lot of wires in connection, the diagram is easy, but practically some difficulties is also there, because the wire is very lengthy, some voltage and current is also passing through it, and heated, and lot of difficulties in the practical session, but and symbol diagram is there, is a ammeter, voltmeter and rheostat, switches and bulb, and then graph diagram is also verified the Ohms law, and same thing. The batteries, important thing is the two batteries are connected in the positively and negatively, this connection is important, because there are closed circuit, minus, plus, minus, plus, minus. Sometimes this is a kept, there are batteries are no connecting, this is a series connection. This is a past paper also, they are in the batteries also connected in the 2 or more batteries, importantly positively and negatively. And bracket switches also there, and the ammeter and resistance and rheostat. The simple one, the simple experiment. This is important. The voltmeter is connected, series connection 1 mark, and voltmeter also with the parallel connection 1 mark, and the rheostat and batteries and switches. This is the diagrams of verify the Ohms law, and reading, get the reading of the volt and ammeter, and the voltmeter and current V over I. This everything, the V over I is a constant value. This one is a constant value. This one is a R. This is a constant value. V over I value is a constant. The V over current is each data. You will observe the constant value of the ratio in the particular temperature. The long time experiment, this value is the difficulties, because the passing through the current is conductor is heated. After that, resistance is also changed. So the experiment is important. They little bit time, give the time to observe particular time intervals, because continuously this experiment, the voltage and amperes is also changing, because the practically this wire is also heated, and after that resistance is also verified. So the and some the Ohms law experiments, V is equal to V over I value is equal to R. So this one is a V is equal to I R. This one is simple experiment, V and I into R relationship, V and I R relationship, V over I. The given simple example, the voltage of 120 volt and current is a 5 amperes. What is the resistance? Simple ones. V is also here 120 voltage, and I is also there 5 amperes A, and V over I, V is equal to I R, V over R is equal to V over I. So 120 upon 5, 24. But here 24, R is equal to 24 ohms. 24 ohms. The current 10 amperes and resistance 3 ohms. What is the voltage? V I R voltage. We find out amperes 10, resistance 3. So 30 voltage. And if battery in a circuit 24 volt and the resistance is 12 ohms, what is the current? V 24 R 12. So V 24 is equal to I is find out and 12. I is a 2 amperes. 2 amperes. House current is 120 volt. Light bulb runs current 0.5 amperes. Resistance of bulb. That's the same thing. Here 24 to 120 volt, and same question is what this here 5 amperes, here 0.5 amperes. So V over I is equal to R. V over I is equal to R, 120 over 0.5. Here 240 ohms. What is the resistance? Resistance is answer is ohms. And your car battery is 12 volt, DC source. Typically you might have the fuse that can be handle 5 amp switch. What is the resistance of the fuse protecting? V is equal to IR. V is equal to IR. V 12 volt, I 5 and R. R is equal to 12 over 5. The 12 volt DC bulb and 5 ampere source. Now, it's a simple one is a V is equal to IR experiment. The V is equal to VOY is equal to constant value, and VOY is equal to R. This is the main things is a current and electricity. The Ohms law is a very important part, and later this part the unit is also in the resistance. There are different type of resistance, and calculate the resultant resistance. But the first thing, how to create and review this subject. The first electricity is produced, static charges and conductors, insulators, how to create the charges, and Ohms law and voltage, and calculate this V is equal to VOYR, and equations, and then here the some circuit is also there, the how to connect this one, the parallelly, and voltage difference. This is some past paper question is also there, the how to connect this this is the voltage drop. Here your textbook is also there, there are a lot of bulb. There are two simple diagram of current passing through the batteries. Here this one is a negative, and this is a negative, and this is a positive, and this is a positive. Here the positive and negative and positive and negative, but this current passing important, their voltage, they are pushing the electron. This there are no voltage difference, there are no potentially the pulling the electrons, though current, there are no current passing through the circuit. But here the important, this is a negatively and positively, and continuously pushing the electron is moving through one, the potentially correct. So, potentially different, this is a circuit is also correct, is working the properly. This question is also there, the batteries, they are positively and negatively charged, sometimes this is no answer, but here the important thing, the potentially difference, the pulling the electron is moved through the circuit. And there are a lot of here the batteries is series connection, batteries is series connection, and parallelly also there. And same thing, this is a batteries, the batteries is parallel connection. There are here two batteries and two batteries, and other experiments also they are same like that. This is positively and negatively, positively and negatively, positively and negatively, and so same thing, the positive and negative, positive and negative. Here the output voltage, the normally 1.5 voltage normal batteries, and this one is all 1.5 voltage. The total 3 voltage is output, because 1.5, 1.5, but this is a parallel connection, but this advancement, this unit is working the long time, because the parallel connection, the voltage is dropping slowly, this one and this one. So, the resultant output is also 3 voltage. Right, this is a voltage, the potentially the parallel batteries is connected is a 3 voltage resultant. Now, is okay, this is a voltmeter connected in parallelly, the reading is also there 3 voltage. The batteries is important, how to connect, this one is a positive and negative, and other the resistance and ammeter is also series connection. Main things is important in the Ohms law, and V is equal to IR. Now, is also the main thing is a V is equal to IR, the Ohms law, and how to connect the batteries and ammeter and voltmeter. The important thing, there are a lot of failures in the question paper, this ammeter and voltmeter, they are a wrong connection is important things. The main thing is consider the voltmeter is connected in the parallelly, and ammeter is also connected in the series connection, and the V is equal to IR, the simple thing is voltage and current and resistance. This equation is memorized, you the easy to answer the question is lot of things is also A level also, and other the important things. The definition is also there. There are no, normally the past paper is there are no definition, but the V is equal to IR, and some structure question is also there O level papers. And other thing is also the resistance, and later is also study about the resistance and type of resistance. Okay, thank you. The next lesson is also start. Other part is also do study about this further, the resistance and how to connect the color value and resistance calculated. So, okay, thank you.